Shock in New York as a vast sinkhole opens up and swallows a van.
This van going straight through the street. That was phenomenal.
In Puerto Rico, a massive blast rocks a community.
We hear the sound of explosion. Everything looked yellow.
In New Zealand's capital, an earthquake tears through a downtown office building.
There'd been complete failure of the floor. You could see that they'd pancaked.
And an explosion in Glasgow destroys a bustling shopping arcade.
And just vroom, right along, and everything just came slamming down on top. Why did it happen to us? Why did it happen here?
With big builds, even the smallest fail can trigger a huge disaster. From miscalculations to misunderstandings, or just plain bad luck. These catastrophes are every engineer's worst nightmare. From the tallest towers to the most complicated infrastructure, engineers build our cities to last. But sometimes there's no escaping the ravages of time. Like this disaster in New York, a massive sinkhole in the middle of a residential street.
We were like, holy crap, like this enormous hole in the ground. I've never seen anything like it.
This brought a whole new meaning to the term underground parking.
This crater was so big, it swallowed an entire van whole.
Leaving residents facing a neighborhood nightmare.
This street just collapsed from within. I was, shocked.
New York. With more than 20 million people calling the metro area home, it's one of the world's so-called megacities and comprised of 5 boroughs.
Today, the Bronx is the fastest growing borough in New York. And if it were a city in its own right, it would rank in the top 10 largest in the US.
With around 1.5 million residents, Bronx reporter Robbie Sikora knows his home has a lot to offer.
The Bronx is the greenest borough in New York City. It is home to the Yankee Stadium and the Bronx Zoo. It's a place where I grew up. I get to cover local news. I love it.
Drawn in by affordable housing, along with Robbie, there are many who began to love neighborhoods like this one. Morris Park in the eastern Bronx. Steph Manacero is a New York TV reporter.
Morris Park specifically is most known for being a very Italian-American neighborhood. There's a lot of Italian heritage. It's very suburban. It has much more of a neighborhoody feel.
But this neighborhood is growing fast, as are the pressures on urban planning.
The modern world depends on a hidden infrastructure network. Everything we need, from electricity and communication cables to gas and water, runs beneath our streets.
The bigger and older the city, the bigger the challenge for engineers to keep it all working.
With more than 10,000 kilometers of drainage pipes, New York's challenge is bigger than most. Dr. George Korfiatis is a professor of environmental engineering.
It's the distance of going from New York to Alaska and coming back. So a lot of pipe underground. A lot of sections are more than 100 years old.
The Bronx was thriving above ground, as vibrant and active as ever. Yet hidden beneath the streets, these aging pipes were about to deal the community a shocking blow. Monday, July the 18th, 2022, New York was hit by torrential rain. TV reporter Steph Manacero hit the streets to cover the deluge.
In the late afternoon, you feel it building, and then the skies open, and it's like boom. And it rained fast, it rained hard.
The storm shut down roads, airports, metro and rail lines. It was chaos.
In the early evening, Steph received a call from the newsroom to head for Morris Park in the Bronx. When she and her crew arrived, they were stunned.
You're like, holy crap, this wasn't here. This whole street wasn't here.
A 12-meter-long sinkhole had swallowed a residential street and was getting bigger by the minute.
All of these people who live in these homes, they were, standing on the sidewalk and just staring at this enormous hole in the ground. It's the size of a city bus, and it just kept crumbling and chipping away and chipping away. Never seen anything like it.
Reporters and residents were powerless to stop the hole. As they watched on, it kept growing. Until finally, 3 tons of white van fell into the abyss.
Just kind of swallowed it. This van just going straight through the street. And I was, shocked.
Like, amazing to watch it all happen. Just couldn't look away.
Luckily, no one was injured in the disaster, but the giant hole had blocked the street to traffic and ruptured a water main below, leaving 70 homes running dry. Residents wanted answers.
I think it was just the gravity of it. The fact that this street just collapsed from within. That was phenomenal.
One potential clue was the extreme weather in the hours leading up to the collapse.
This area was being battered by a heavy storm, which brought with it record levels of rainfall. And the Bronx seemed to be getting the worst of it, with over 8 centimeters of rain, more than twice the amount that was recorded next door in Manhattan.
It seems the trouble started with a combined sewer and storm drain below the street that had been installed in 1916, more than a century earlier, and wasn't designed to handle nearly as much water as the storm dumped on the Bronx.
They had said that, they had kind of had issues with the street infrastructure when it rains. When you have heavy downpour, it is overexhausting these sewer systems.
Under normal conditions, the contents flow downhill under gravity. But when these massive storms add huge amounts of extra rainwater, the pipes are suddenly pressurized, which can cause cracks, forcing water into the surrounding soil.
With the aging pipes filled to the brim and breaking apart, it was a disaster waiting to happen.
What happens is that when the pipe pressurizes, the water springs out, and then soil starts flowing into the pipe. And then what happens is the soil is washed away, and as it's washed away, there's a void behind it. And that void expands.
No one knows how long the gap around the crumbling pipe had been forming, hidden underground. But the huge summer storm was the final straw.
If you have very short duration, high intensity rainfall, a lot of water is dumped in a short period of time, then the system gets overwhelmed. Water starts coming out of the hole with force, and it erodes it further. Then what happens is that as more and more soil is washed away, that's when that sinkhole happens.
I think the sheer aspect of a van falling into an enormous hole in the street gets people's attention. It's not something you see every day.
Although this sinkhole went viral, it was actually the second to occur on this street, within a year, and left anxious residents wondering, was there more going on here than just aging infrastructure?
What you find a lot of these events is that there isn't a way to prepare for them. There isn't a way to understand the gravity or the effects of what's going to happen. It almost kind of seemed like it was this wake-up call.
In fact, sinkholes are becoming more common across the entire city.
Sinkholes are notoriously hard to predict, but right now, they're on the rise across New York, with up to 4,000 holes opening up in recent years.
The uptick might not be due to aging infrastructure alone. but an increase in extreme weather events too.
I think it's a synergistic effect between the effects of climate change combined with the aging of the infrastructure.
The research is still in its infancy, but there appears to be a correlation between climate change and increase in sinkhole formation, with extreme weather, increases in temperature, and sea level all playing a part.
For the Bronx's Morris Park, the short-term solution was simple. The aging pipes were replaced, and the road was filled in.
Luckily, as you see, they were able to patch it up 6 weeks after it happened.
For the long run, plans are in place to increase the city's drainage pipe capacity, along with high-tech monitoring measures to keep an eye on the aging infrastructure beneath the streets.
According to officials, the city is installing real-time flood sensors and working with the US Geological Survey to create a comprehensive underground map of the area's hydrology.
With both repairs and prevention measures in the pipeline, authorities are hopeful that sinkholes like this will become a thing of the past.
Growth is generally a positive thing, but a population boom has to go hand in hand with the right infrastructure to support it, not just above the ground, but below it as well.
In big engineering, every piece, no matter how small, plays a vital role. If just one thing goes wrong, the consequences can be catastrophic. Like this disaster in Puerto Rico, as chaos broke out at an oil storage facility.
30 years responding to emergencies, nobody saw something so big like that.
A seemingly minor malfunction with massive consequences.
Esto es tan sencillo como tener una bomba en el mismo medio de la ciudad.
This explosion was so huge, it damaged homes more than a mile from the facility.
Puerto Rico is an island of contrasts. From the tropical rainforests to modern cities. Historian Dagmar Galaza Hernandez has spent the last 2 decades here.
Que le hace especial para alguien que nunca haya venido es que en relativamente poca distancia tiene una biodiversidad de paisajes y de vida.
The island has an abundance of natural riches for the more than 3 million people who live here. But one thing it lacks is oil.
Puerto Rico relies on imported fuel. And it's not just to keep traffic moving. Much of it is burned in power plants, generating around a third of the island's electricity.
El petróleo para Puerto Rico, pues lamentablemente es vital. Somos, como tantísimos otros países en el mundo, dependientes completamente del petróleo.
For decades, much of that oil has been stored in a massive tank field here on the outskirts of San Juan, carrying everything from crude oil to gasoline.
Reabastece el petróleo y luego por ahí lo distribuyen y se convierte en comodidad. Así que lo que tenemos detrás nuestro es vital para hospitales, para la vida cotidiana, para todo.
But in 2009, this crucial facility was at the center of an event that shook the island. Around midnight, Thursday, October the 22nd, volunteer fire chief Yolando Pinheiro was relaxing at home. As the clock turned to Friday, his peace was interrupted.
We hear and feel the sound of explosion. So as soon as we look to the sky, everything looked yellow.
Local Javier Almeida saw the blast. It had come from the fuel storage facility.
Cuando llegué aquí, lo que se veía era una explosión que iluminaba todo el cielo. Jamás en la vida había visto algo así, ¿no? Me dio temor.
I know that something bad happens and I have to go there to see what we can do.
Yolando and his fellow firefighters headed to the scene. They were some of the first responders to arrive.
When we start was a total chaos because it was 13 tanks burning up.
Authorities shut down air traffic, nearby highways, and evacuated more than 3,000 people from the surrounding area. While emergency crews went to work, they knew that this fire couldn't be extinguished with water.
Oil and water don't mix, so spraying water can cause the burning oil to spread, making things even worse. Instead, firefighters have to smother the oil with a special foam.
We don't have in the whole island enough quantity of foam concentrate to fight this fire. And we have to start bringing from other industries here in the island or from other islands in the Caribbean.
The National Guard was called in, deploying their own vital supplies of fire-retardant foam.
Fue bien importante la ayuda de la Guardia Nacional en extinguir el fuego porque contaban con muchas facilidades de lo que se utiliza de espuma.
Even so, it still took firefighters 72 hours to extinguish the blaze. Miraculously, there were no casualties, but 17 of the 48 tanks were destroyed, and the surrounding community had been devastated. Materials scientist Edgardo Rodriguez witnessed the scale of the damage.
Esa explosión está tan fuerte que en la población bien cercana produjo en una de ellas casi la pérdida de 230 y pico de residencias altamente impactadas. Rompió puertas, rompió verjas.
Yo recorrí esta misma avenida, la vegetación, toda la vegetación completamente quemada. Completamente quemada. Todo se afectó. Como si hubiesen tirado una bomba que lo hubiese desaparecido todo.
This facility, vital for keeping Puerto Rico's fuel supplies flowing, was a smouldering ruin. And the full impact on the island was still unknown.
Entonces, el día que se apaga el fuego, ese día el impacto medioambiental no termina.
President Obama signed an emergency declaration, triggering multiple support measures to be sent to the territory. Now, everyone wanted to know just what had caused the disaster. Authorities launched an immediate investigation into the events leading up to the explosion. At the time, crews were conducting a routine transfer of unleaded gasoline from a ship to 4 tanks on site, when operators saw a low-lying white cloud spreading across the facility.
Los mismos inspectores empezaron a percibir un fuerte olor, un fuerte de gasolina.
The workers recognized that this was highly flammable gasoline vapor and locked down the facility while they investigated further.
Workers had good reason to be concerned. Vapor cloud explosions are the most destructive events in the petrochemicals industry.
El vapor que genera la gasolina es altamente peligroso, ya que tiene los mismos componentes que tiene la gasolina, tiene las sustancias que son más volátiles.
All that was needed was a spark, which the vapor found in the facility's system for cleaning stormwater runoff.
El vapor llegó a la área de manejo, de tratamiento con los motores que habían allí. Aparentemente fue la que inició esa pequeña chispa.
That small spark lit the fuse, and around 750,000 liters of fuel ignited, triggering blasts that registered 2.9 on the Richter scale. That explained the devastating explosions, but the big question was why had the fuel been overflowing in the first place? Investigators pinpointed the cause to the system used to monitor the tank levels.
Liquid levels in the tanks were monitored by a relatively basic float and tape device.
The float on the surface of the fuel was attached to a metal tape. As it moved up or down, the level could be read from a gauge on the outside. And here, that information was also transmitted to the control room.
But on one of the tanks, the information wasn't getting through to the control room.
Uno de los problemas principales que se determinó fue que los sensores automáticos no estaban funcionando, no llevaban ni transmitían la información de forma apropiada.
Because the automated system wasn't working, operators were manually checking the gauge on the tank every hour, and they calculated that the tank would be full by around 1 a.m.
Investigators analysed the ship's pump logs and discovered that the tank had been filling much faster than the side gauge was showing. In fact, the key problem wasn't the lack of automated level data, but the gauge itself, which was giving a completely false reading.
Once that float and tape system failed, there was nothing to prevent the tank from overflowing.
El defecto en la medida y el defecto en identificar que se estaba sobrellenando produjo que se liberaran del tanque.
The equivalent to 20 tanker trucks full of gasoline overflowed from the huge cylinder.
As the fuel overflowed undetected, the disaster was almost inevitable. All it needed was the spark from the stormwater treatment plant. The inquiry concluded that multiple technical and systemic failures had contributed to the disaster, including the faulty float and tape gauge. They all came together to cause the explosion and its terrible environmental impact.
Fue el comienzo de la detonación de montones de impactos ambientales que todavía tienen que estarse calculando.
More than a decade later, the tank field is under new ownership and continues to store critical fuels for the island, while nationwide changes were made to require fully functioning automatic systems to both detect and stop an overflow.
One key lesson is that independent safety systems are vital. So if one goes down, there are layers of redundancy and backups in place to help prevent something like this from ever happening again.
Es bien importante que estos eventos no queden en el pasado. Le da la oportunidad al país y evitar repetir errores.
Engineers design structures to withstand anything the elements can throw at them. But if there's any sign of weakness, nature will find a way to exploit it. Like this disaster in New Zealand, as titanic forces rocked the capital, Wellington.
This earthquake was one of the strongest in New Zealand's history,
with structures across the city tested to the limit.
The entire floor was really rolling and shaking. It was very frightening.
Revealing a decades-old weakness in an iconic office building.
The underpinnings of the research and development really wasn't there. Wellington, New Zealand's capital. Nearly 500,000 people live here, perched beside a natural harbour, surrounded by seismically active terrain. Journalist Phil Pennington was born and raised in Wellington.
We've got major fault lines that run right through the city, so you've got real dynamic features going on. I think it makes it a very interesting place.
The forces that shaped this landscape can be incredibly destructive too.
New Zealand sits where the Australian and Pacific tectonic plates collide. The ongoing movement triggers thousands of earthquakes every year, many of them strong enough to destroy buildings.
New Zealanders have long known the geological risks. But in 2011, nature gave them a brutal reminder when the city of Christchurch, about 400 kilometres away, was rocked by a magnitude 6.3 earthquake.
This is what happened actually in the Christchurch quake. You had the collapse of some of the unreinforced masonry.
Although the damage to historic brick and stone buildings was widespread, recent steel and concrete structures also suffered major damage, including 2 which fatally collapsed. The tragedy prompted nationwide inspections of large office and residential buildings for vulnerabilities. Even before these investigations, New Zealand had long been at the forefront of research into earthquake-proof structures. Professor of Civil Engineering Rick Henry is a leader in the field.
For a very long time, we've been constructing with earthquakes as one of the primary drivers of our design.
Central to designing structures to be earthquake resistant is allowing them to move without collapsing, so-called ductile design.
And these are buildings which are constructed of frames, so a series of columns and beams that make up the building, where unique members of that building are designed to be damaged during the earthquake.
The principle behind ductile design is similar to that of a car's crumple zone. The frame absorbs the energy from the earthquake, and although it might get damaged, the building stays standing. Or at least, that's the theory.
Starting in the 1980s, Wellington saw an over 2-decade-long boom in multi-story structures clustered in the central business district, most with ductile reinforced concrete frames, including this 6-story office building completed in 2005.
This is quite a common example of the type of building that we built. When this building is subjected to lateral demands in an earthquake, we're relying on the frame to resist those forces and allow the building to resist the earthquake demands.
For nearly a decade, the building stood strong against multiple quakes, until one spring night in 2016. Monday, November the 14th. It was midnight and the capital Wellington was quiet, when suddenly the earth began to move. Just outside the city, journalist Phil Pennington was at home asleep.
We got out of bed in a hurry. The entire floor of the house was shaking. We knew to get under the door frames, and we were there with the children, 4 young children, as the house was really rolling and shaking. It was very frightening.
The ground rocked for 2 minutes, and the 7.8 magnitude quake left residents terrified.
Most of the quakes around here are 5 or 6 on the Richter scale, and this is a 7.8. It was the biggest quake we've ever been in.
Reports came in that the central business district had been hit hard. When Phil arrived, the damage didn't appear to be as bad as he feared.
The odd person in the street, some broken glass in the street.
Although things looked okay on the surface, closer inspection revealed serious damage inside some structures, including this supposedly earthquake-resistant 6-story office block, which was cordoned off by emergency services.
If you looked in through the big glass doors and there was ceiling panels hanging down, a lot of mess inside. There'd been complete failure of the floor in places where the concrete beam from above had fallen, so you could see that it had pancaked, not pancaked completely, but was on an angle.
Floor beams across 2 levels had crashed down onto computers and office equipment below.
Luckily, the quake struck in the middle of the night when the offices were empty.
If the quake had happened during working hours, people probably would have been killed.
The earthquake was felt across the country and left many ductile-designed structures in the business district beyond repair.
So in the days following the quake, there was initial seismic assessments done by engineers looking visually at buildings to see if there was cracks or anything was off kilter, anything that would have an immediate risk to people underneath. Some of the streets were cordoned off, quite a lot of buildings were cordoned off.
As investigations continued, one burning question was why this office and other modern structures built to be earthquake resistant had suffered such serious internal damage.
You couldn't actually tell from the outside that there was much of a problem. That's when they began to find out the problems that had hit quite a few buildings. In fact, I think they had about 80 buildings on their list.
With this office block, the damage to the inside was massive.
And it really became the guinea pig, if you like, to find out what had gone wrong, to get more clues about particular vulnerabilities in other commercial buildings, and then what to do about them.
Inspections revealed that despite the internal collapse, the building's ductile frame had successfully done its job. Civil engineer Rick Henry examined the findings.
The structural system actually performed in a way as it was intended, resisting the earthquake demand and maintaining the sort of support to the structure.
But investigators discovered a key issue, where the building's floor slabs met its frame.
If we look at earthquake observations particularly, for precast concrete, the failure is always at the connection between components.
Here, like in many countries, the ductile design philosophy hadn't extended to the interior floor slabs.
Precast concrete floors are prefabricated units, and so they're made at a factory, shipped to site and lifted into position. They're more like components where they're put into the building rather than properly tied in and integral to the structure.
Where the floor slabs met the supporting beams, they rested on a 75mm wide ledge.
We often refer to that as sort of a binary engineering, where the precast unit is sitting on a support, just resting really.
On solid ground, this would work well, but when the earthquake shook the ductile frame, it flexed, and the columns at each end separated by 100mm, which was more than the width of the supporting ledge.
And what that means is that if we get a stretching of 100mm between these columns, the precast floor is sitting on the beams and they're slowly moving apart away from it. And so it's a bit like a deck of cards where it's sitting on the ledge of the beam and that beam is slowly shifting.
As the slabs slid from their shelves, the floors crashed down from a lack of support. In fact, before the earthquake, engineers were aware of the risk and were in the process of fixing it.
The plan was to install steel brackets beneath the end of the slabs. That would prevent them from falling from the frame.
When the quake struck, 2 of the floors were reinforced with brackets, and those floors withstood the quake.
This has been a really effective mechanism to support these double Ts as that potential collapse occurs.
While only 3 out of dozens of slabs failed on the lower floors, the risk of further collapse was too severe, so the decision was made to tear the building down. Authorities had learned their lesson, and in 2018 ruled that any new construction could not include precast floor slabs designed to sit on ledges like this.
What the earthquakes have brought to light is the real vulnerabilities of precast concrete floors. So they're still looking into just how they fail and especially how to retrofit them, because 60% of the commercial building stock in Wellington is thought to have these floors.
Efforts are underway to strengthen existing structures, while this failure provided valuable lessons for engineers as they design the buildings of the future.
I think we've learned a thing or two, maybe. Things have improved a bit since maybe 2005.
One big lesson from this failure was that although a building is made up of thousands of pieces, the key is to predict how they'll all work together in a disaster.
From the magnificent to the mundane, engineering is a vital part of our daily lives. But sometimes, that everyday engineering can cause the deadliest disasters. Like this catastrophe in Scotland, an underground fire that quickly turned to a deadly blast.
Just vroom, right along, and everything just came slamming down on top.
It was travelling faster than the speed of sound, and then the flame became an explosion.
Devastation on a scale that left people demanding answers.
Why did it happen to us? Why did it happen here?
Glasgow, Scotland's largest city, has a strong industrial past. But booming industry and residential living don't always go hand in hand. As local journalist Norrie Wilson knows only too well.
As Glasgow grew, all of a sudden, the slightly well-to-do folk that were living in the centre of the city found themselves surrounded by factories, belching furnaces, noisy, smelly industries. So the great sort of migration started. Slowly but surely, we spread south.
Many settled here, in the lush, peaceful suburb of Clarkston.
Not a lot happens in Clarkston. It's a quiet place. Originally a very, very small village, which has just sort of grown over time, but pleasantly so.
Convenient road and rail links were developed, making it easy for consumers to access this shopping hotspot.
I remember as a small boy, it was a landmark. It was this low-level, single-storey shops with rooftop car park above. Rooftop, you'd never seen anything like it.
But this isn't the first shopping arcade on this site. The original, built in the 1960s, came to an untimely end.
People were drawn here by the lure of a quiet life, but the peace was about to be shattered by an event that sent shockwaves across the country.
Thursday, October the 21st, 1971. A rainy afternoon in Clarkston did nothing to keep shoppers from visiting their favourite stores. At 2:52 p.m., their world was turned upside down. A huge explosion ripped through the heart of Clarkston.
The power of a World War II bomb right in the center of the community.
The entire row of shops was destroyed in seconds, with a blast so loud it was reportedly heard around 16 kilometers away.
The blast was so powerful that it completely flattened buildings.
Just vroom, right along, and everything just came slamming down on top.
And it wasn't just buildings that caught the full force of the blast.
A double-decker bus had just pulled into the bus stop. The bus and passengers, they caught a major bit of the explosion.
First responders raced from every corner of Glasgow to help.
More ambulances than I'd ever seen in my life. It's not just one ambulance or two ambulances, dozens of ambulances.
The rooftop parking had also come crashing down, sending more than 20 vehicles plummeting into the devastation below. George Loudon witnessed the destruction firsthand.
It was horrendous. People trapped. I could see roofs of cars, but that was all I could see. I can't really compare it to anything, but the state of the building that I've seen, horrendous.
Despite the heroic efforts of everyone involved, more than 100 people had been injured, many seriously. 22 more people lost their lives in the fatal tragedy.
The largest and most fatal explosion that Scotland's ever witnessed.
This tragic explosion in a crowded shopping street had all of Scotland demanding answers.
There was a real sense of shock. It's this nice, sort of small, quiet commuter community, and all of a sudden it has been absolutely devastated.
Crucial evidence was at risk of being destroyed in the search for survivors, so authorities urgently launched an investigation. Now an architect, Gordon Gibb was just a child when his father, a forensic fire investigator, was called to the scene.
Just before evening meal, the police came to the door to take my father to escort him to Clarkston. We then later found out that he was to head up the investigation of this explosion.
For Gordon's father, William Gibb, the scale of the devastation was unprecedented.
We all saw him for the first time at breakfast the next morning. And I remember my father being very shocked by what he'd seen, but he really had to focus on his own job, which was to find the cause of the explosion.
Although the blast was compared to a 130-kilogram bomb, the cause wasn't explosives, but another deadly substance that had been detected days before the disaster: gas.
Locals going about the shops for at least 3 or 4 days before the event had reported a strong smell of gas.
People were feeling sick, so people working in the basements of the shops had recorded feeling unwell.
In fact, the gas supplier had been actively trying to establish the source of the leak. George Loudon was an apprentice gas engineer at the time.
Our engineers had been on site for quite a while looking for this gas escape. They knew that there was a gas escape with the smell, but the gas escapes are not easy to find. So the question was, where did the gas come from?
Searching through the wreckage, William Gibb discovered a damaged gas pipe that had been underneath the pavement in front of the row of shops.
So this was excavated, and it was found that in this section there was a crack.
The inquiry discovered that the gas main below the shops had corroded and fractured and had been leaking deadly gas for around a week before the explosion.
The gas percolated through the soil into a void space between the higher level of the road and the lower level of the shop basements, and the space between these two filled with gas.
Undetected, gas was slowly escaping from a metre below the road surface into unventilated basements. And at 2:52 p.m. on a Thursday, it finally ignited. A fireball quickly spread beneath the entire row of shops before exploding up through the structure.
As it did so, it was accelerating and accelerating. It was travelling faster than the speed of sound. And that's when you have that degree of enclosure and nowhere for the flame to go, is when the explosion will happen.
While authorities were able to determine most of the factors contributing to the disaster, the source of ignition remains a mystery to this day.
What actually sparked the explosion? I mean, they'll never know whether it was someone lighting a cigarette or as simple as you going down to a basement and switching a light on.
But one key question remained. Why had a gas pipe that was no more than 6 years old ruptured in the first place? It seems the pipe wasn't sufficiently held in place beneath the road, allowing it to move around, which was bad news for a pipe made of cast iron.
It was made of cast iron, and so there was no flexibility in it. The cause of the fracture was a lack of support in the ground below it. So when the ground was flexing as a result of traffic passing near, the pipe would move.
Years of movement every time a vehicle passed above caused the inflexible pipe to crack. And as the gas leaked undetected, the seeds of disaster had been sown.
Ironically, the popularity of the shops in the rooftop car park may have inadvertently played a part in this tragedy.
The following year, Scotland's longest inquiry into a fatal disaster concluded that the catastrophe was accidental and no blame was ever assigned.
Nobody was found guilty, nobody was found culpable. So at the end of the day, you're still left sort of hanging. Why did it happen? And why did it happen to us? Why did it happen in Clarkston?
Nothing prepares you for what we found that day. Over all the years, colleagues, friends of mine, nobody ever talks about it.
In the years after the collapse, the row of shops was rebuilt, almost as it had been before the disaster. And inflexible cast iron pipes were replaced with more durable options.
In the UK, cast iron is no longer used to carry gas supplies. Instead, it's been replaced with plastic piping. It's far more flexible and it won't corrode, helping to prevent disasters like this in the future.
For many years after the Clarkston disaster, my father gave lectures to local authorities, fire officers and other groups about the dangers of gas conduits and void spaces. And I'd like to think that the information that he gave to others resulted in the changes that we now see. I was at the memorial for the 50th anniversary. It has a very powerful impact still today.